Okay, here's another problem for your review. A cubic salt crystal expands by accumulation on all sides. As it expands outward, find the rate of change of its volume with respect to the length of an edge when the edge is 0.38 millimeters. And so what we have to do is remember that we're dealing with a crystal, and they tell us that it's a cube, so it's got a shape, something like this. This isn't exact. My artistry is not that awesome, but we've got this cube, and what's happening is the sides are expanding. So what's going to happen is that this cube right here is going to get bigger and bigger and bigger. And let's see if we can get a good look at what that might look like. So here's my cube, and what it's doing is it's going to grow and become bigger. Okay? And so we want to know, how is my cube changing when the side is 0.38 millimeters? And to do that, we just need to find the limit as the length of the side is equal to 0.38 millimeters. We're going to use this guy right here. This is my f. This is like think f of x equals x cubed, and think at x equals 0.38. This is what you need to think. And then when you've got this set up, then we can come back over here. Here's my limit rules. Here's my limit rules, and we can just go, all right, what is f of 0.38? And find out what that is, and what is f of 0.38 plus h, and find out what that is. And once we get these two things solved out, we can use our limit rule, and it should be not too horribly challenging, but there will be a lot of decimal places carried around, so that could be a little bit of a challenge. F at 0.38 is just simply 0.38 cubed. And if my calculator hasn't deceived me, that's going to be 0.054,872. And so then this guy would be 0.38 plus h cubed. And so remember, what's going on here is I've got 0.38 plus h times 0.38 plus h times 0.38 plus h. And you have to FOIL all of those guys out. And so when you FOIL out the first two guys, again, as long as I'm punched stuff into the calculator correctly, this is what I get. 1.444 plus 0.76h plus h squared, and then all of that again times 0.38 plus h. And so, everything in the front times everything in the front times everything in the back. And when you do that, you should end up with 0.054872 plus 0.288h plus 0.38 h squared plus, I'm running out of room here, 0.144 h plus 0.28 h h squared plus h cubed. Whew, that's a long one. All right. So when I set my limit up, when I set up my limit, I'm just going to take this guy right here. This guy, let's see here. This guy right here minus this guy right here. And then let's see if I can cancel the h's out and see what happens with things going to 0. So Here we go. Hopefully I've left myself enough room. 0.54872 plus 0.288 h plus 0.38 h squared plus 0.144 h. And when you get to the minus part, always open up parentheses or brackets. But you just never know, and it'll save yourself a lot of heartache later. Just make it a habit. That way you're sure to carry the minus sign through everything in the back. This one's not too much to worry about. There's only one term. But if there was multiple things in the back, then they would all need to go away. Alright, so now that I got this part done, check it out. These guys go away right off the bat. By the way, these are all over h. And this is the limit as h approaches 0. So those guys go away. And I could combine some like terms in here if I wanted to, but honestly, I don't want to mess with all the decimals. However, once these guys are gone, everything that's left has an h in it. And so I can get rid of or cancel out or reduce out an h from here, an h from here, an h from here, an h from here, and an h from here, and an h from here. And so what I'm left with is the limit as h goes to 0 of 0.2888 plus 0.1444 plus 0.38h plus 0.2888h plus h squared. And then I'm going to let h go to 0. So can I put 0 in now and have an equation that's not a problem? And the answer is yes, I can. All of these guys go to 0. So I'm left with 0.2888 plus 0.1444. And again, if my calculator hasn't deceived me, this would be 0.4332 for your final answer. And what is it? That's the rate of change that the volume is changing with respect to the length. And so there's your final answer. How quickly is the volume changing? It's changing by this many millimeters cubed.